Dear colleagues, my name is Andrii Kopp, and together with my colleague Dmytro Orlovskyi, we would like to present our study, Computational Technology and Software Tool for Translation of Business Rules into Database Creation Scripts. In our presentation, we are going to describe a motivation for this project, outline the main ideas, developed software tool and experiments, discussion, and conclusion. So almost all modern software systems are using databases and database management systems to store and manage data collections and ensure their persistence and security. Agile software development methodologies do not assume engineers focus only on database design or any other specific field. Database design usually belongs to the scope of software developers responsible for server-side programming. Hence, a lack of specialized skills and experience may lead to database design shortcomings or even errors, causing time and money expenses at the later stages of software development projects. When software requirements are elicited, database entities and relationships are captured in business rules, brief and precise descriptions of a considered domain. Therefore, we propose a computational technology and a software tool for the translation of business rules into database creation scripts to reduce time and cost expenses at the development or maintenance stages of software engineering projects. Let's begin with the business rules processing and formalization. Business rules are supposed to be given as controlled language structures of limited grammar and complexity as given here. And a deterministic finite-state machine, which state chart is demonstrated, is used to parse business rules to extract entities and attributes. Then, to demonstrate some example of preliminary extraction of entities and attributes using deterministic finite-state machine, we propose to consider this business rules example, which describes a domain of students, courses, and enrollments. At the next step, we have to detect relationships between entities, and they can be detected using common attributes, primary keys in parent entities and foreign keys in child entities. To detect relationships, we propose to check all pairs of entities and find intersections of their attributes. An entity that firstly mentions the common attribute according to our algorithm should be considered as parent entity, while other entities as child. And the sample entities were extended with the relationships for the example are demonstrated here. Next challenging task is to suggest attribute data types using only their names. In our paper, we use the Spider NLP dataset created and supported in Yale University. This dataset includes 166 databases with various tables that cover 138 different domains. Using the metadata descriptions of database tables from the Spider dataset, we prepared the set of attribute names and their data types for the association rule learning Apriori algorithm. But the Apriori algorithm couldn't find data types for columns that are not present in the data set. Therefore, we propose the attribute data type suggestion using name conventions. We use the following set of keywords to augment the association rules algorithm by checking how attribute names match naming conventions. Examples of attribute prefixes or suffixes for number, timestamp, and Boolean attributes are demonstrated here, and some of attributes from our example, such as course number and number credits, were adjusted with the number identified data type instead of default text data type using this extension. So the proposed computational technology includes 4 major steps: entities and attributes extraction using deterministic finite-state machine, relationships, primary keys, and foreign keys detection using ER modeling concepts, attribute data types suggestion using Spider dataset and a priori algorithm, and naming conventions approach, and SQL data definition code generation using the DDL commands syntax. The proposed computational technology includes algorithmic model of three main algorithms: relationship detection algorithm, attribute data type suggestion algorithm based on association rules, and attribute data type suggestion algorithm based on naming conventions. Currently, a software tool is developed as a Python command line application that takes several arguments, such as name of the business rules text file, name of the output SQL scripts file, and the name of target database management system. Our solution is compatible with four popular database management systems: Oracle Database, MySQL, Microsoft SQL Server, and PostgreSQL. The structure of software tool developed is demonstrated here. It uses additional Python package natural language toolkit to tokenize business rules and filter stop words. The usage of software tool demonstrates how business rules given in the plain text file as a collection of sentences are transformed into the sequence of SQL commands for tables creation and relationships creation among these tables. And we have tested our scripts with mentioned database management systems: Oracle, MySQL, SQL Server, and PostgreSQL, and confirmed that produced SQL scripts are deployable to these popular relational database systems. Obviously, obtained SQL statements require adjustments of data types or constraints if necessary under the decision of developer. Performance evaluation of our tool proved that proposed solution is capable of processing large volumes of business rules and generate SQL database creation code for different popular database management systems in reasonable time, even for large input collections of business rules. To discuss, we can say that business rules were successfully translated using our solution into SQL code, and these scripts were successfully tested with different database engines. Performance testing demonstrates capability of solving large problems for SQL code generation in a reasonable time. But there are several limitations because we assume the usage of only controlled language statements with a restricted structure as business rules. The detection of relationships between entities could fail if don't mention primary and foreign keys as common entity attributes explicitly. However, it's a common practice actually to name key attributes as we consider exactly in our approach. Among 166 databases present in the Spider dataset, 163 databases, which is 89%, are using shared names for primary and foreign keys. And to conclude, we say that considered problem is relevant for the reducing time and cost when database design errors could arise at the later stages of software product development. For this purpose, we propose deterministic finite-state machine for business rules parsing, algorithms for data types detection for attributes, and the algorithm for relationships detection among the entities. And proposed computational technology includes all of these proposals plus the SQL code generation toolkit as the implementation. And in the future, our solution should be augmented by algorithms that can detect constraints in business rules, and a web-based software solution should be developed for a better user experience. Thank you very much for your attention, and I'll be glad to answer your questions.